Hey everyone, and welcome back for another deep dive.
Yeah.
Today we're going to be looking at something pretty interesting.
Oh, yeah.
Yeah, it's using piezoelectric materials
Okay.
to generate energy. So basically putting them in roads and harnessing the power of, cars driving over them.
Okay.
We've got a bunch of research papers and articles to go through, and we really want to see if this tech
Right.
lives up to the hype. So is it really a green solution, or is it just, a lot of hot air?
Well, it is interesting you say that about the hype because it's not exactly a brand new concept.
Right.
The piezoelectric effect itself was discovered way back in 1880.
Wow, that's a long time ago.
Yeah, by the Curie brothers, no less.
Oh, wow. So the same Curie.
Yeah.
From like Marie Curie.
Well, her husband and his brother.
Oh, okay. Interesting. But just to back up a little bit,
Okay.
for those of us who maybe haven't taken a physics class recently,
Right.
what exactly is the piezoelectric effect?
So you can kind of think of it like squeezing a lemon
Okay.
to get juice.
Yeah. You apply pressure and you get a result. In this case, electricity.
I like that analogy.
Yeah. And the really neat part is it also works in reverse.
Oh.
You apply electricity to the material and it moves.
Wow. So it's kind of like a two-way street.
Right.
Pressure makes electricity, electricity makes motion.
Exactly.
Really cool. And the Curie brothers, they use natural crystals for their experiments, right?
Uh-huh.
Like quartz?
Yeah, like quartz, which, is used in all sorts of things even today.
Yeah, like watches.
Exactly.
But I'm guessing when it comes to like generating a significant amount of power,
Yeah.
those natural crystals probably have some limitations.
You're right. Natural crystals like quartz, they're great for some things,
Yeah.
but they just don't have the oomph for large-scale energy harvesting.
Okay, that makes sense. So that's where those man-made materials come in.
Exactly.
And I know from the research that the most common one is PZT, lead zirconate titanate.
Yeah, it's a mouthful, isn't it? It is. That name sounds like it could power a whole city on its own.
Uh-huh. Right.
But it's probably not that simple, huh?
Unfortunately, it's not. PZT is very good at converting energy. I'll give it that.
Okay.
But it's also brittle,
Oh, right?
which isn't ideal if you want to embed it in a road surface that has to take a beating every day.
Yeah, good point.
And even more importantly, PZT contains lead,
Oh, right. Yeah,
which, raises environmental concerns.
for sure. So it's not quite as eco-friendly as it might seem at first glance.
Right.
So where does that leave us?
Well,
Are there any alternatives that don't have those drawbacks?
there are, and that's where things get really interesting.
Okay, tell me more.
We're talking about materials like zinc oxide, ZNO for short, and barium titanate. That one's Batio-3.
Okay, I'm taking notes. So what makes these lead-free options better?
Well, for one, ZNO is super versatile.
Okay.
It can be used for all sorts of things. And it's less dense than PZT, which could be a real advantage for large-scale projects.
Yeah, less weight would definitely make a difference when you're talking about roads.
Yeah, absolutely. Now, Batio-3 is kind of a different beast.
Okay.
It has what's called a high electromechanical coupling factor.
Hold on. I gotta stop you there.
Oh, okay.
Electromechanical what now?
Haha, yeah, it's a bit of a mouthful. But basically it just means that Batio-3 is really efficient at converting mechanical energy into electrical energy.
Oh, okay. So the higher the coupling factor, the more electricity you get from the same amount of pressure.
Exactly. You got it.
So Batio-3 is like the overachiever of the piezoelectric world.
Uh-huh. You could say that.
But can these materials really handle the demands of a busy highway?
That's the million-dollar question, isn't it?
Yeah.
And to answer that, researchers are delving into some pretty advanced stuff. They're looking at how to basically enhance the properties of these materials, like doping and sintering techniques.
Okay, now you're just using big words to try and impress me.
Haha, not at all.
Kamen, break it down for me. What do those techniques actually involve?
Okay. So doping is kind of like adding a secret ingredient to a recipe.
Okay.
You introduce tiny amounts of other materials, like nanomaterials, into the base material.
Okay.
And that can actually change the whole crystal structure and electrical conductivity of the material. It's pretty amazing, really.
Wow, so they're basically fine-tuning the material at a microscopic level.
Exactly. And then there's sintering.
Okay, what's that?
Sintering is all about using heat and pressure to make the material denser, more durable. Think of it like turning a pile of sand into a solid brick.
Ah, I see.
Advanced sintering techniques let scientists really control the microstructure of the material.
So they're creating these super-powered versions of these piezoelectric materials.
They are, and that's really pushing the boundaries of what's possible.
That's incredible. But all this lab work is great, but has anyone actually tried this stuff out on real roads?
They have.
Really?
There's this fascinating case study from the N1 highway in Pretoria, South Africa.
Okay.
They put piezoelectric generators at a toll gate.
To see if they could actually power something.
Yeah, they wanted to see if they could power the streetlights.
Oh, wow. So those streetlights are literally running on car power.
That's the idea.
It's amazing. So did it work?
Well, the results were pretty promising.
Right.
They chose a spot with a ton of traffic.
Makes sense.
The Pumalani Plaza toll gate, which has like 6 dual-lane carriageways.
Oh, wow.
They did a bunch of calculations looking at traffic volume, the weight of the vehicles, the speed they were going, how efficiently the generators could convert the energy.
Yeah.
And they figured out that the system could generate about 1.57 kilowatt hours per day.
Okay. And is that enough?
It is. That's enough to power 6 250-watt streetlights.
Wow. That's pretty impressive.
It is, oh.
But there's a but.
There's always a but. Think about it. Streetlights need power at night.
Yeah.
But most of this energy is generated during the day when people are driving.
Oh, right.
So how do you bridge that gap?
Yeah, that's a good question. I mean, you could use batteries, right?
You could, but traditional batteries aren't really the best fit for this kind of thing.
Why not?
Well, they have a limited lifespan.
Right.
And they don't like extreme temperatures.
Oh, yeah. Good point.
You wouldn't want your streetlights flickering on and off as the weather changes.
Uh-huh. Yeah. Definitely not.
That
So what's the solution then?
supercapacitors.
Supercapacitors. I've heard of them, but to be honest, I don't really know what they are.
They're pretty cool, actually. Think of them as a hybrid between a capacitor and a battery.
Okay.
They can store a lot of energy very quickly, like a capacitor,
Okay.
but they can also release it slowly, like a battery.
So the best of both worlds.
Exactly.
And what makes them so good for piezoelectric energy harvesting?
Well, they can handle almost unlimited charge and discharge cycles without wearing out.
That's important when you have a lot of cars driving over those piezoelectric generators.
Right. And they're much less sensitive to temperature changes than batteries.
So they're much more reliable for outdoor use. Supercapacitors sound like a pretty crucial piece of the puzzle.
Yeah, they are.
But I have a feeling there's a lot more to this technology than what we've talked about so far, right?
Oh, absolutely. What we've covered is really just the tip of the iceberg.
Really?
Piezoelectric materials have applications that go way beyond roads, you know.
Like what? Give me some examples.
Well, think about sensors, for instance, like the microphones in your phone, or the devices they use for medical ultrasound imaging,
Huh.
or actuators, which create movement, like the motors in inkjet printers.
Oh, I had no idea.
They're everywhere.
So this isn't just some far-off futuristic idea, then
Oh,
it's already all around us.
it is.
It makes you wonder what the future holds for piezoelectric energy harvesting. What are the researchers focused on now to make this technology even better?
Well, a lot of the current research is focused on those lead-free materials we were talking about,
Okay.
ZNO and BaTiO3.
Right. Yeah.
They're looking into some seriously cutting-edge techniques to improve them, like doping with nanomaterials and advanced sintering.
So they're basically trying to create super-powered versions of these materials.
Exactly.
That's incredible. You know, I gotta say, I'm really starting to see the potential of this whole piezoelectric energy harvesting thing.
Yeah, it's pretty amazing.
It's like something straight out of a science fiction novel, but it's actually happening.
It is.
So for everyone listening, let's quickly recap what we've learned so far about piezoelectric energy harvesting.
Okay.
We started with the piezoelectric effect itself,
Right.
that amazing ability of some materials to convert pressure into electricity and the other way around.
Yeah.
We talked about the history, starting with natural crystals like quartz, moving on to those man-made materials like PZT.
Right.
We learned about the challenges with PZT,
Yeah.
like how it's brittle and contains lead,
Right.
which led us to those exciting lead-free alternatives.
Exactly.
ZNO and BaTiO3.
Uh-huh.
And we even touched on those super advanced techniques like doping and sintering
Yep.
that scientists are using to enhance these materials and make them even more efficient.
It's a rapidly evolving field.
It is. Okay, now that we've laid the groundwork, I'm going to hand it over to you to leave our listeners with something to think about. What's a big question they should be asking themselves about the future of piezoelectric energy harvesting?
Well, here's something to ponder. What if we could integrate piezoelectric energy harvesting into other infrastructure elements, not just roads?
Okay, I like where this is going.
Imagine sidewalks that generate power with every footstep, or train tracks that capture energy from passing trains, or even airport floors that harness the energy of, like, thousands of travelers.
Wow, that's a lot of footsteps.
It is. It's mind-boggling when you think about the possibilities.
Really is. What breakthroughs in material science could unlock the full potential of this technology? It's pretty exciting to think about.
It is, and I think we're only just getting started.
Mind-boggling indeed. I know I'll be thinking about that long after this deep dive. Thanks for guiding us through this fascinating world of piezoelectric energy harvesting.
It's been my pleasure.
And to our amazing listeners, thank you for joining us on this electrifying journey. Stay curious, and we'll see you next time for part 2 of our deep dive into piezoelectric materials and their potential to power the future. Welcome back to our deep dives into the world of piezoelectric energy harvesting. Before the break, we were talking about those mind-blowing possibilities like sidewalks that generate power from footsteps.
Yeah,
It all sounds pretty futuristic.
it does.
But I imagine there's some pretty big hurdles to overcome before we see this tech embedded in our cities, right?
Yeah, you're right. It's not just about, slapping some piezoelectric materials on a surface and calling it a day.
Right.
There are definitely some real challenges when it comes to actually scaling this technology up for widespread use.
Okay, so what are the biggest roadblocks then? What's standing between us and those energy-generating sidewalks?
Well, one of the main challenges is efficiency. Okay. Right now, only a small percentage of the mechanical energy that you put into a piezoelectric material
Right.
actually gets converted into usable electricity.
Hmm.
A lot of energy is lost during that conversion process.
So we need to find ways to basically make that conversion process more efficient,
Right.
to squeeze more electricity out of every footstep or every passing car.
Exactly.
What are researchers doing to address that?
Well, there are a few different approaches they're looking at. One is developing new piezoelectric materials
Okay.
with higher electromechanical coupling factors.
Right, the coupling factor.
Exactly. Remember, that's a measure of how well a material converts mechanical energy into electrical energy.
Right, yeah, so basically finding materials that are better at making that energy conversion.
Exactly.
What else are they working on?
They're also trying to optimize the design
Yeah.
and the structure of the energy harvesting devices themselves.
Yeah.
So the shape and the arrangement of the piezoelectric elements
Right.
can really impact how much energy they can actually capture.
So it's not just about the material, but how you actually design the system that uses it.
Yeah.
It's kind of like how the shape of a wind turbine blade affects how much wind energy it can capture.
That's a great analogy.
And then, of course, there's the whole electronic side of things.
Right.
You need some pretty sophisticated electronics to manage all the electricity that's generated.
Yeah, absolutely.
The electricity that comes out of these piezoelectric materials can be pretty unpredictable.
Yeah, it can be all over the place depending on how much pressure is applied,
Right.
how often the vibrations are happening.
So you need some smart electronics to smooth things out, basically.
Yeah,
To
exactly.
make sure there's a consistent and reliable power output. Like,
Yeah.
imagine a street light that flickers every time a car drives by.
Uh-huh, right.
Not very practical.
Not at all.
So what do those electronics actually do?
They basically regulate the voltage and the current.
Okay.
So you get a nice steady flow of power.
It's amazing how much intricate engineering goes into something that, on the surface, seems so simple.
Right.
Pressure creates electricity.
Yeah, it's more complicated than it sounds.
We can't really talk about challenges without talking about cost, right?
Of course not.
How expensive is it to actually implement piezoelectric energy harvesting right now? I mean, is it something that cities can realistically afford?
That's the big question.
Yeah.
And to be honest, the materials
Yeah.
and the manufacturing processes are still pretty expensive,
Right.
especially when you're talking about these large-scale projects.
So paving all our roads with piezoelectric materials is still a pretty pricey proposition.
Yeah, for now at least.
Is there any hope of bringing those costs down in the future?
Absolutely. There are a lot of researchers looking into that right now.
Okay, good.
One promising avenue is using polymer-based piezoelectrics,
Polymer-based as opposed to?
as opposed to ceramics, which are the most common type right now.
Okay.
Polymers are generally cheaper to make, so
Yeah.
that can make a big difference.
Are there any other strategies for making this tech more budget-friendly?
Yeah. Researchers are also exploring new manufacturing techniques,
Okay.
ones that are more scalable and less resource intensive.
Yeah,
If we want to see piezoelectric energy harvesting all over the place,
right.
we need to figure out how to make these devices really efficiently and economically.
It all comes down to scalability, right?
Yeah.
I mean, it's one thing to build a prototype in a lab, but it's another thing entirely to produce these things on a massive scale.
Exactly.
And of course, we can't forget about the environmental impact.
Right.
I mean, we talk about the benefits of using lead-free piezoelectric materials,
Yeah.
But what about the overall environmental footprint of actually making these
It's
devices?
a good point. We don't want to solve one problem,
Yeah.
like our reliance on fossil fuels, and
Right.
create another problem in the process.
So what do we actually know about the environmental impact of producing these piezoelectric materials?
Well, that's an area where more research is definitely needed. We need to look at the whole life cycle of these materials,
Yeah.
from the raw materials to the manufacturing
Right.
to how they're disposed of or recycled.
So basically, taking a holistic view
Yeah,
and making sure that the environmental benefits outweigh any negative impacts from their production.
exactly. It's all about finding that balance.
And it's not just about the materials themselves, right?
Right.
We also need to think about the environmental impact of actually installing these systems.
Yeah, like tearing up existing roadways and putting in the new systems.
Right, the construction process itself has a footprint.
Exactly.
It's a complex equation with a lot of different factors.
It is.
It seems like we're still in the early stages of really understanding the environmental implications of this technology.
Yeah, we're still learning.
But that's what makes this field so exciting.
It is.
It's dynamic, there's so much to discover, so much potential for innovation.
Absolutely.
What are some of the research areas that you're most excited about right now?
Well, one area I find really fascinating is the development of bio-inspired piezoelectric materials.
Bio-inspired, what does that even mean?
Basically, we're looking to nature for inspiration.
Okay.
Nature has already solved a lot of the engineering challenges that we're facing.
Oh, interesting.
Like bone is a naturally piezoelectric material.
It is.
It is. And it's incredibly strong and resilient.
Hmm. So are scientists basically trying to copy bone to create better piezoelectric materials?
Yeah, pretty much. They're studying how bone is structured,
Right.
what it's made of.
To try and figure out how it works so well.
Exactly. And they're using that knowledge to design new materials that can do the same things.
That's amazing. It's like biomimicry or something.
It is, yeah.
Learning from nature's designs.
hmm
I mean, nature's had billions of years to perfect its designs, so
Right.
why not learn from the best?
Exactly. And another really cool area of research is self-healing piezoelectric materials.
Self-healing? Like, what, Wolverine?
Uh-huh. Yeah, kinda.
That sounds crazy.
It does, but researchers are actually making real progress on this.
Wow.
They're putting special polymers into piezoelectric materials
Oh,
that can actually repair small cracks or damage.
really?
Yeah, it's wild. So they last longer and you don't have to replace them as often.
That's incredible. It'd be like roads that could fix their own potholes.
Uh-huh, exactly.
Imagine how much money that would save
Right.
and how much less maintenance would be needed.
Yeah, it's a game changer.
And it all comes back to that bio-inspiration thing.
Yeah,
Learning from the amazing abilities of living organisms.
exactly.
It makes you wonder what other incredible things we could learn from nature if we just paid attention. Who knows what else is out there? You know, this whole conversation has really shifted my perspective. I used to think of roads as just, well, roads.
Right.
But now I see them as potential sources of energy, just waiting to be tapped.
That's a great way to look at it. And it's not just roads.
Right.
It's bridges, buildings, vehicles. Everything has the potential to be part of a more sustainable future.
It's like a paradigm shift,
Yeah.
seeing energy potential everywhere.
That's what's so exciting about this field.
Yeah.
It's not just about a single technology. It's about a whole new way of thinking about energy.
And how we interact with the world.
Exactly. It's about harnessing the power of our everyday actions to create a better world.
I'm feeling pretty inspired right now, gotta say.
Me too.
So for our listeners, what are some of the key takeaways you want them to remember from this deep dive into piezoelectric energy harvesting?
I think the most important thing is that this is still a young technology.
Okay.
It's not going to solve all of our energy problems overnight,
Right.
but the potential is huge.
Yeah.
And research is moving really fast.
It's not just about the tech itself, but about that change in mindset.
Right.
Seeing energy potential all around us.
Exactly. And those advancements in material science,
Yeah.
manufacturing, taking inspiration from nature, it's really incredible.
We do.
We're seeing these new materials that are stronger, more efficient, even self-healing.
It's a good reminder that nature is the ultimate innovator
For sure.
and that we still have so much to learn from it.
Absolutely.
We've covered a lot of ground today,
Yeah,
but I feel like we've only just scratched the surface.
we have.
There's so much more to explore.
There is.
But before we wrap up this part of our deep dive, I'd love to hear your final thoughts on the future of this technology.
Okay.
What are you most excited about and what are you most hopeful for?
What excites me the most is the potential for piezoelectric energy harvesting to just become completely ubiquitous
Ubiquitous, meaning
everywhere,
basically.
seamlessly integrated into our everyday lives.
Okay.
Imagine a world where our phones charge wirelessly just from us walking around, or
Mm.
our homes are powered by the vibrations of our footsteps,
Wow.
or cities are lit up by the energy of traffic flow.
Well, it's like a utopian sci-fi novel.
Aha! Yeah, it is.
But it's a beautiful vision.
And what I'm most hopeful for is that this technology can help us create a more sustainable future.
Right.
One where we don't have to rely so much on fossil fuels.
Right.
And we can live in harmony with our planet.
It's a future worth striving for, that's for
Yeah,
sure.
I think so.
You know, I used to think about renewable energy as something that required these massive solar farms
Yeah.
or giant wind turbines.
Yeah.
But piezoelectric energy harvesting shows us that it can be something that's all around us,
Right.
in our cities, our homes, even our clothes.
It's about distributed energy generation, tapping into the power that's all around us.
It's a truly revolutionary concept.
It is.
I have a feeling we're going to be hearing a lot more about piezoelectric energy harvesting in the years to come.
I think so.
And stay tuned for the final part of our deep dive, where we'll delve even deeper into the potential applications of this game-changing technology. Welcome back to the final part of our piezoelectric power journey. You know, as we've been talking about all these really cool applications,
Yeah.
it's kind of amazing how this tech connects different fields, you know.
It's like biology is inspiring material design, nanotechnology is meeting energy solutions.
Uh-huh.
It's pretty wild.
Yeah, it really shows how everything is connected these days. Science isn't just happening in these little silos anymore.
Right.
And as we learn more from how nature solves problems, we can apply those same principles to our own technology.
Exactly. Nature's had billions of years to figure things out.
Exactly.
Earlier, we were talking about how these systems actually work.
Yeah,
And you mentioned supercapacitors as being really important.
right.
Could you remind us again why they're such a good fit for piezoelectric energy harvesting?
Sure. Supercapacitors have some real advantages over traditional batteries, especially for this kind of application.
Okay.
They can handle those really fast charge and discharge cycles without breaking down,
Right.
which is super important when you're dealing with that irregular energy flow.
Right, from things like footsteps or traffic.
Exactly.
It makes sense. Like, a normal battery wouldn't last very long if it was constantly getting hit with these tiny charges.
No, not at all. And we talked about the environmental challenges earlier.
Yeah.
Are supercapacitors any better in that regard?
That's a really important question, and honestly, it's still something researchers are working on.
Sure.
Some types of supercapacitors use materials that are more readily available and less toxic
Okay.
than the stuff you find in some batteries.
Right.
But like with any new tech, we really need to look at the whole life cycle impact, you know?
Yeah, from start to finish.
Exactly.
So it sounds like supercapacitors have huge potential, but we still need to do more research to make sure they're truly sustainable.
I think that's a fair assessment.
Okay, cool. So, switching gears a bit.
Okay.
For anyone listening who's thinking, this is awesome, I want to get involved, where do they even start?
Haha, good question.
What kind of field should they be looking into?
Well, there are a lot of different ways to get involved depending on what you're interested in.
Okay.
Of course, material science is at the core of all this.
Makes sense.
Those are the folks who are developing the next generation of piezoelectric materials.
So all you aspiring scientists out there, time to dust off those chemistry sets.
Haha, exactly.
But it's not just about the materials themselves, right?
Right. You also need electrical engineers to
Yeah.
design all the circuits and systems that capture and manage the power.
Oh, right, of course.
And then you have the mechanical engineers who design the actual structure and shape of these energy harvesting devices.
So it really takes a team.
It does, yeah. It's a truly interdisciplinary field.
I bet there's a pretty big demand for people with these skills right now, huh?
Oh, yeah, definitely. As this tech takes off, the need for skilled professionals is only going to grow.
Makes sense.
It's a really exciting field with tons of potential for growth, both for research and for applications.
It's inspiring to think about all the brilliant minds out there working to make this technology a reality.
It is.
Okay, before we wrap things up, I want to go back to an idea that really stuck with me.
Okay.
It's the realization that energy is literally all around us.
It is.
Everywhere.
It really is a powerful shift in perspective.
Yeah.
We tend to think about energy coming from these big power plants or gas stations, but really it's everywhere. In every vibration, every gust of wind, even our own movements.
Piezoelectric energy harvesting is just one example of how we can tap into that hidden energy,
Yeah, exactly.
It's a good reminder that innovation can come from anywhere,
Yeah.
and that even our everyday actions can help us create a more sustainable future.
Absolutely. And that's what I find so hopeful about this whole field, really.
Yeah.
It's not just about one specific technology, it's about thinking differently about the world around us.
Right. Like how we interact with our environment.
Exactly. And how we can use those interactions to create positive change.
Well said. Well, folks, we've reached the end of our deep dive into piezoelectric energy harvesting.
It's been a fun journey.
I hope you're leaving with a sense of wonder and maybe even some inspiration to think about the world in new ways.
I hope so too.
And to all of our amazing listeners, thank you for joining us on this electrifying journey. Stay curious, keep those questions coming, and who knows, maybe one of you will be the one to unlock the next big breakthrough in piezoelectric energy harvesting. Until next time, keep those minds sparking.